Hello students, I am Rashmi Vadwa, Assistant Professor of Science and Institute of Technology and Management, Gurgaon from ETCE department. Student, today's topic is short on stability test and applications of FFT. This is the topic from your first unit, and almost in last video I covered my third and fourth unit, and remaining 2 or 3 topics left from the unit 1. So I'm covering these topic. So what do you mean by FFT? आपने ये टॉपिक पहले भी पढ़ा है, and that is the fast Fourier transform. And the FFT has a lots of application, and it's used extensively in audio processing, radar, sonar, and software defined to name but a few. आपने जैसे लास्ट वीडियो में स्टूडेंट्स DFT एंड FFT पढ़ा था, अगर आपको याद हो तो जब आपने DFT एंड FFT पढ़ा था तो हमने उस पे बेस्ड न्यूमेरिकल्स भी किए थे, उस पे बेस्ड एल्गो भी किए थे. तो बेसिकली जो फास्ट फोरियर ट्रांसफॉर्म है एल्गो था, दैट डिटरमाइंस द डिस्क्रीट फोरियर ट्रांसफॉर्म ऑफ एन इनपुट सिग्निफिकेंटली फास्टर देन कंप्यूटिंग इट डायरेक्टली. Or FFT also reduces the number of computations needed for a problem of size n from n raised to power 2. So it reduces the computations also. And in audio radar software in sub may extensively use it and has a lots of applications. And when we are talking about the fundamental behind the uh, Fourier transform is that it is possible to decompose a time varying signal into sine waves. For example, FFT can be used to calculate the amplitude and the frequency of all sine waves that make up audio signal. A spectrum signal analyzer will use the FFT and show individual sine wave as peak in its display. And all the applications of FFT, a time domain signal is converted by FFT into frequency domain signal representations, all this. And when we are talking about the daily life or real life application of FT, so there are the many there are used in many computational algos that require convolutions and that have nothing to do with signals, and they are using in numerical solution of the ordinary and partial differential equation, which we can use to model almost anything. And when we are talking about the more applications of FFT, so signal processing deals with modification and analysis of the acquired time series data for the purpose of analysis or enhancement. For example, includes spectral analysis, the fast Fourier transform, and enhancing acquired data using digital filtering. A fast Fourier algo is used to compute DFT and simply characterize the magnitude and phase of the signal. It can be used in a combination with other operations to perform more involved computations such as convolution and correlations. And when we are talking about other applications of FFT, is that it's basically just to compute the DFT. And when we're talking about its advantage, then it helps the converting time domain and frequency domain, which makes the calculation easier as we always deal with various frequency band in the communication system. Other big advantage of the FFT is that converts the discrete data into the continuous type of data available at various frequency. Also, FFT is a mathematical methods for transforming the time into a function of frequency. Means that हमारे को time से frequency में जब function change करना, that's why we are using FFT. Sometimes it is described as a transform from the time domain to frequency domain. It is very useful to analyze of time dependent phenomena. So these all are the applications of 4 to 5 marks. May sometimes the question asks the what are the application of FFT, और व्हाट डू यू मीन बाय FFT और DFT? सो आपको पता होना चाहिए व्हाट डू यू मीन बाय these applications. There's also applications of DFTB, that is spectrum analysis, spectrograms, filters and correlation analysis, power spectral density estimation. These are the applications of DFT as well. Now come to the one more topic, that is Shorn-Cohn stability test. See, one concept of stability of system, basically for LTI system, this is the Shorn-Cohn stability test. But whenever come to the point of stability, we talk about the poles and zeros of the system. जब भी हम stability की बात करते हैं, because the poles lie on the left side, the system is stable, lie on the right side, system is unstable, lie on the imaginary axis, stable is system is marginally stable. So when we are talking about the stability, we go for poles. So in this topic, we discuss how to realize stability by using jet transform through some technique. But still in this method, we are going to consider the poles of the system. So the Shorn-Cohn stability test: for a system to be stable, all poles of the system should lie inside the unit circle. There are the several procedures which helps in determining the location of roots of aged polynomials that lie outside of the unit circle. So one of the such procedure is termed and Shorn-Cohn stability test. Here this for example ये totally numerical है, numerical भी करेंगे हम, इससे क्वेश्चन सॉल्व करेंगे तो पता चल जाएगा कि स्टेबिलिटी कैसे चेक करते हैं. Here the system function is given by Hz, so Hz is equals to Bz by Az. Az is my polynomial which is equals to 1 plus a1z1, a1 z inverse plus a2 z square, z minus 2 plus up to so n a n z raised to power minus n, or amz is equals to summation am k z minus k is equals to 0 and m, where first polynomial am is 0 is always 1, and Vz is equals to z raised to power minus m, am z raised to power minus 1, यानी कि z inverse. So which is equals to am m minus k z की power minus k summation k raised to power m. Here bm is the term reverse और reciprocal polynomial. आप देख भी सकते हैं जो यहाँ पर amz था, amz you can see here, this is amz, तो इसका रेसिप्रोकल कर दिया amz इनवर्स. दैट्स व्हाई आई एम सेइंग bz is equals to reciprocal and a reverse polynomial. In this amz we calculate the different values of k, that is k1, k2, k3 and k4. This k1 is represent poles where a n z is equals to az and kn is equals to q and n. So two important formulas are here, but you can see here there is a two formula am minus 1 z is equals to am z minus km bm z 1 minus k square m. Basically m is an order and km is equals to am into m. You can see here there are the two types of am. एक कैपिटल ए एम है, एक स्मॉल ए एम है. So capital AM is it is a polynomial and small am it is a some coefficient of polynomial with some exponential power of z. So the differentiation between am and a capital am and small am should be clear to you. For stability, the condition that needs to be checked is km is mode of km is less than 1, and if and only if this condition is satisfied, then all roots will lie on inside the. अगर ये condition satisfy होगी तो ये हमारे सारे जो है lie करेंगे inside the unit circle. ये stability ये condition check करने के बाद हम चेक करेंगे सिस्टम स्टेबल है या नहीं है. सो देखिए एक एग्जांपल लिया है हमने. H1z is equals to 1 minus 1 upon में 1 minus 7 by 4 z inverse minus 1 by 2 z inverse. This is bz by az. So the order of az, highest order of az क्या है मेरा यहाँ पर 1 minus 7 by 4 z inverse minus 1 by 2 z की पावर -2. हाईएस्ट पावर क्या है m is equals to 2 आ गया. And when we are comparing this equation by this one, this like ये वाली, so यहाँ 1 a नॉट मेरा 1 हो जाएगा. a1 a2 की वैल्यू निकालनी है इस न्यूमेरिकल में. a नॉट मेरा 1, a1 यहाँ से कोफिशिएंट 7/4 माइनस का a2 यहाँ से -1/2. सो k2 इज इक्वल्स टू कैसे आ जाएगा -1/2. ये कैसे है km इज इक्वल्स टू am/m है, तो m is 2. So a2 is equals to -1/2. So according to this condition, k2 mod of this mod of 1/2 is less than 1. Yes. So system is stable up to this point because this condition, only this condition satisfied. But now use formula number 1. Formula number 1 and 2 बहुत important है. Formula number मेरा 1 था a m minus 1 ना, ये रहा a m minus 1. so m है 2, 2 minus 1 1 हो गया. So that is equals to a2z, यहाँ m की जगह 2 पुट कर दिया, k2 b2z 1 minus k square 2. So b2z is equals to what? a2z square z inverse into z minus 2. So पहले first of all a2z, then multiply in z is replaced by z inverse. You replace z by z inverse and multiply by z square. Then you multiply by z square and you will get what? b2z. So this is b2z. Now b2z is this one, a2z is this one, and k की हमारी वैल्यू निकली हुई है. k2 is 1/2. Put these values 1 minus 7/4 z इनवर्स. यहाँ पे आपने ये क्या वैल्यू रखी है a2z, यहाँ पर आपने k2 की वैल्यू रख दी, ये b2 की वैल्यू हो गई, ये भी k2 की वैल्यू होगी. पुट ऑल दीज वैल्यूज एंड जब आपने इसे सॉल्व किया यू विल गेट 1 minus 7/2 z इनवर्स. आपने इसको मल्टीप्लाई कर दिया, सॉल्व कर दिया, तो ये आ गया. तो यहाँ पर हाईएस्ट ऑर्डर क्या है m is equals to 1. a नॉट क्या आ गया 1, a1 क्या आ जाएगा -7/2 विच इज इक्वल्स टू k1. कैसे आया ये देखिए इस फॉर्मूले से. k1 m की वैल्यू 1 थी, am यहाँ से ले लिया, a1 is equals to -7/2. So according to the condition k1 is equals to -7/2, that is 3.5, which is greater than 1. अगर if this is less than 1, then system becomes unstable. The question यही रुक जाएगा, because it is greater than 1, system is unstable. This is my Shorn-Kohn stability test with the help of this two formulas, which is very important. So this is the topic from first unit. एक बार पेपर में आया हुआ है AMDU के अंदर क्वेश्चन 4 मार्क्स के स्टार्टिंग के क्वेश्चन में, व्हाट डू यू अंडरस्टैंड बाय शॉर्न-कोहन स्टेबिलिटी टेस्ट. सो अगर फिर इस वीडियो में बहुत अच्छे से क्लियर कर दिया है मैंने, और इसके ऊपर हमने बेस्ड एक न्यूमेरिकल भी ले लिया है. तो आपको पेपर में यही लिखना है, 4 to 5 मार्क्स में आता है या 7 मार्क्स में आता है. थैंक यू स्टूडेंट्स, थैंक यू सो मच.